Hello everyone, and welcome to Reservoir Engineering, 2 Fluid Properties. In the previous reservoir engineering lecture, we focused on rock properties, porosity, permeability, and compressibility. Now we move to the other half of reservoir behavior, the fluids. Reservoir fluids control pressure response, flow behavior, recovery efficiency, and ultimately how much oil and gas we can produce. This week you will learn how reservoir engineers describe fluids using laboratory measurements, PVT concepts, and key multiphase flow functions used in reservoir simulation. Let's quickly place this lecture in the overall course. We have already covered geology, geophysics, drilling, petrophysics, and well logging. Then we entered reservoir engineering with rock properties. Today is Development 2, Fluid Properties, which is the natural next step because reservoir performance is controlled by both rock and fluid. After this week, we will move toward reservoir modeling and simulation, where these fluid properties become direct input data. Here's the roadmap for today. We begin with an introduction to PVT and how fluid properties are measured. Then we study capillary pressure. Next we cover relative and effective permeability. After that we focus on water and crude oil properties and connect them to fluid saturation. Finally, we recap the key learning points and preview what comes next. Think of this week as learning the fluid language of reservoir engineering. Reservoir fluid properties are normally measured in the laboratory using PVT analysis, where PVT stands for pressure, volume, and temperature. These 3 variables define the thermodynamic state of reservoir fluids. In reservoir engineering, PVT properties are essential because they control volumetric calculations and pressure-volume behavior during depletion and injection. The key idea is reservoir fluids behave differently at reservoir conditions than at surface conditions, so we need a systematic way to relate those conditions, and that's exactly what PVT analysis provides. This slide shows a typical PVT analysis system and reminds us that PVT measurements are done with specialized high-pressure equipment. A PVT cell is basically a high-pressure vessel that allows engineers to control pressure and temperature while measuring the fluid volume and phase behavior. This is where we obtain the ground truth for fluid properties such as formation volume factors, compressibility, and viscosity under reservoir conditions. Later, if we don't have lab data, we may use correlations, but lab data is always the highest reference. In addition to lab measurements, reservoir PVT properties can also be estimated using equations of state, or EOS. An EOS relates pressure, volume, and temperature through theoretically derived relationships. Classic examples include cubic EOS forms and real gas-type equations. In practice, engineers also use PVT correlations, which are empirical relationships built from large datasets of lab measurements. Correlations can be very useful for early-stage studies when lab data are limited, but they are not always as accurate as PVT experiments or EOS calibrated to lab data. This slide also introduces isothermal compressibility, which describes how volume changes as pressure changes at constant temperature.